Hello friends, so in this video I will discuss about differentiation. Basically we will discuss about calculus. Specifically, if you try to understand, it will be differentiation, or you can say it is derivatives. So as I move on, I will explain what are the benefits of understanding this fundamentally. There are a lot of applications of differentiation and derivatives. You have an applications in different kinds of fields of science and technology. So let's take an example. Let's take an example of a straight line where y is equal to mx plus c. You know that. So if we plot a line like this, so this is a straight line. Consider it is a straight line, and this is, we can say this is some angle theta, the x-axis, this angle theta, and m is equal to tan of this theta, which is also called slope, and c is intercept. If you see here, this will be c. So now here, if you see that x is x, this is actually independent variable. So, and y, this is dependent. So basically y is dependent on x. In other words, it means that as x changes, y changes. So if you see in the straight line here, this is one point, this is another point, this is another point. In each of these data points, if you see here, this is x of this point. For this is x, and for this is x. So x value is changing. This might be 5, this might be 2, this might be -2. So x is varying. As x is varying, you can see this y is also varying. Here y is this much, here the y is this much, and here the y is this much. So this is the equation of line. So the benefit of doing differentiation is that we can understand at which location of this straight line, suppose this point we are talking of, at this point, if we change a little bit of x, how much will be the change in y? That is the application of derivatives of differentiation. Now if you write differentiation, so it is written as dy by dx, or in other words, you write it like this: limit delta x delta x tending towards 0 and delta y over delta x. So this means as the x changes, y changes, but here what it's saying is the change in y given the change in x. So for a unit change in x, what is the change in y? That is the main motive here. But the change in x should be very, very small. That this limit is telling the changes should be very, very small. Okay, so it tells that what is the change in y when there is a change in x, or you can say the change in y given unit change in x, and very small means if we are talking of this point, data point, this data point I'm talking, this data point, here you will shift x by a very minimal amount, very small point, because as the x is changing, y is changing with different amounts. But here, since it is a straight line, it is constant. Otherwise, in different curves, it will be varying at different x. So dy by dx is always calculated at a specific point, like this, or could be like this, or could be like this, or could be like this at this data point also. Now if you, so there are basic formulas, so how to calculate dy by dx. For y is equal to mx plus c, dy by dx will be, m is constant, you write it like this, and then you calculate dx over dx, differentiation of this part with respect to dx we are doing, plus dc by dx. But since c is constant, so the change in constant is always 0, so this part goes to 0, and dx over dx is same thing, so this becomes 1, so this is equal to m. So dy by dx is basically, you can say, m. In turn, m is also a slope here, which I have defined here. M is slope. So we can say that at a given point like this, whatever the slope we have, and the slope which we calculate geometrically is at any given data point, what you do is you create a tangent there, and you calculate the angle, this angle with the x-axis, and then you take the tan theta. So if you take any other curve like this here, and if you want to calculate the slope here, what you would do is you create a tangent, this is tangent, and you take the theta, and then you take the value of tan theta, this one. So this will be the value of dy by dx at this data point. Now if you have, say, some function like x to the power n y, so dy by dx will always be n x to the power n minus 1. So if you have y is equal to x square, then dy by dx should be 2x2 minus 1, which is 2x. So in this video I have just given a basic idea of what is differentiation, and I have tried to connect it with the geometrically. In the next video I will try to connect it with the applications and try to give more insights so that you can connect that how you can use it in different applications. Thank you.